We now discuss the solution of a problem from the section Differential Calculus. And this problem is on the concepts of continuity and differentiability of a given function. This question has appeared in the joint entrance examination main held on 24th June 2022 in the second session. The problem is, let f of x is equal to sine of in brackets x minus bracket x or box x by x minus bracket x when x belongs to the open interval -2 comma -1, and maximum of in brackets 2x comma 3 times bracket of mod x when mod x less than 1 and it is 1 otherwise, where bracket t or box t denotes the greatest integer less than or equal to t. If m is the number of points where f is not continuous and n is the number of points where f is not differentiable, then the ordered pair m comma n is, we are given four options. Option A 3 comma 3, option B ordered pair 2 comma 4, option C ordered pair 2 comma 3, option D the ordered pair 3 comma 4. So we are given this function f of x defined like this, and here m denotes the number of points where f is not continuous, that means f is where f is discontinuous, and n is the number of n is the number of points where f is not differentiable. Then you have to find the ordered pair m comma n. We now discuss the solution of the problem in detail, and we have this function. So right now it has three branches. We now first consider the first branch. F of x is equal to sine of in brackets x minus bracket x by x minus bracket x, where x belongs to the open interval -2 to -1. Now, when x belongs to open interval -2 to -1, then bracket x is -2. That is the greatest integer not exceeding x is -2. So go back and substitute wherever there is a bracket x, you substitute -2. Then f of x is equal to this function, and substituting we'll get sine of x minus of -2 by x minus of -2. That will be sine of x plus 2 by x plus 2 when x belongs to the open interval -2 to -1. So that is the first branch. Now let's get into the second branch. The second branch is the maximum of 2x comma 3 times of bracket of mod x. So this is the second branch what we have considered, and this is in when mod x less than 1. Now when mod x less than 1, mod x belongs to the semi-closed interval 0 to 1 closed at 0 end. Yes, it can take the value 0 also. So when mod x belongs to this, then what will be the bracket of mod x? Mod x belongs to the semi-closed interval 0 comma 1 closed at 0 end, then the bracket of mod x will be 0. Yes, that is the greatest integer not exceeding mod x. So when mod x less than 1. and fx now becomes, the above one now becomes the maximum of 2x comma, this will become 0 when mod x less than 1. So f of x is equal to maximum of 2x comma 0 in the interval minus 1 less than x less than 1, that is mod x less than 1. Let's look at the diagram. So x-axis, y-axis, and x is equal to minus 1 and x is equal to plus 1. So this will be the open interval minus 1 to plus 1. Now y is equal to 0. This is y is equal to 0 in the blue, and y is equal to 2x in the red. Now what will be the maximum of 2x comma 0 in the open interval minus 1 to 0? So the maximum of 2x comma 0 in the interval minus 1 less than x less than 0 is 0, because look at the uh, graph. So this is your 0, this is the y is equal to 2x. The maximum is this one only, the maximum is this, and the maximum of 2x comma 0 in the interval 0 less than or equal to x less than 1, obviously the red one, that is y is equal to 2x. 2x will be the maximum. So the maximum of 2x comma 0 is 2x in 0 less than or equal to x less than 1. So this will be equal to, f of x will be equal to 0 in the open interval minus 1 to 0, and is equal to 2x in the semi-closed interval 0 to 1 closed at 0 end. So now how the graph will now look like? So the graph will be like this. The graph will be like this. Agreed. Note that, and what about is it continuous at 0? That's what we are asking. Is it continuous at 0? So what we have seen is limit extends to 0 minus. Limit extends to 0 minus. That means the left limit extending to 0 is 0, and the value of f at 0 is 2 times 0 is 0. So that means limit extends to 0 minus of fx is 0 and is equal to f of 0, and therefore f of x is continuous at x is equal to 0. But now what about its differentiability at x is equal to 0? And because it is continuous, we cannot say it is differentiable at x is equal to 0. Note that f of x is not differentiable at x is equal to 0. Why? Because it has a corner at x is equal to 0. It has a corner at x is equal to 0. At corners, differentiability is lost. That means the curve is not smooth at x is equal to 0. So the graph of fx has corner at x is equal to 0. With this reason, f of x is not differentiable at x is equal to 0. And f of x is continuous at x is equal to 0, but it is not differentiable at x is equal to 0. Now we proceed further. We have the function f of x is like this. Now the second branch is now is broken into two sub branches. That what we have seen in the last slide. Now, so these are all continuous functions, and these are continuous. Fx will be continuous except possibly at this x is equal to minus 1, x is equal to 0, x is equal to 1. So where these curves are connecting, is the continuity is maintained or not? That's the question. So it is continuous everywhere except possibly at x is equal to minus 1, 0, 1. Now note that limit extends to minus 1 minus, that is the left limit. The left limit this way, left limit is sine 1 by 1. So sine 1. And limit x tends to minus 1 plus f of x. That is the right limit. The right limit is 0. The right limit is 0. They are not equal. So there is a jump that it's taking place. Therefore, it is discontinuous. So they are not equal. Therefore, f of x is discontinuous at x is equal to minus 1. We have already seen at f of x is continuous at x is equal to 0 and f of x is not differentiable at x is equal to 0. Now what happens at x is equal to 1? So now limit x tends to 1 minus 1 minus means what? 1 minus means the left limit, that is 2 into 1, 2. The right limit is 1. The right limit is 1. And they are not equal. The jump takes place. Therefore, they are not equal. Therefore, f of x is discontinuous at x is equal to minus 1. So, at these 3 points, possibly continuity is there or not. We have seen at x is equal to minus 1, it is discontinuous. At x is equal to 0, it is continuous. At x is equal to 1, it is again discontinuous. Now, it is given m is the number of points where the f of x is not continuous. So m is the number of points where f is not continuous, that is f is discontinuous, is 2. Is 2. So we have to see the the number of points where f of f where f is not differentiable. We have to see that. We will see in the next slide. So this is the scenario so far. So far what we have done is this, and the m is the number of points where f is discontinuous is 2. Now we recall f of x is differentiable at x is equal to a, implies f of x is continuous at x is equal to a. This is a very standard result. Differentiability implies continuity. And if f of x is discontinuous at x is equal to a, then f of x is not differentiable at x is equal to a. So this result follows from the above. So f of x, if it is discontinuous, then it is not differentiable. It is discontinuous, f of x is discontinuous at x is equal to minus 1 and discontinuous at x is equal to 1. Therefore, f of x is not differentiable at x is equal to minus 1 and 1. And we have already seen that f of x is not differentiable at x is equal to 0. So on the whole, f of x is not differentiable at x is equal to minus 1, 1 and 0. So now n, what is n? N is the number of points where f is not differentiable is 3. Is 3. So therefore m comma n is the one what we have to find out, and that will be m is 2, n is 3, 2 comma 3. That is the ordered pair. So let us look at our options, and our answer 2 comma 3 appears against option C. Therefore our answer for this question is option C. And this will be definitely be an interesting question, and it may take little time in the examination, but however, uh, once in a while questions do come which will take some extra time. So I'm sure that you have understood the solution of this problem, and I wish you all the best. Thank you.